Hey everybody, welcome back to another SAT video. This is a question from the 2024 practice bundle number 6, math module 2. How many distinct real solutions does the equation have, right? So how would we go about solving this equation regularly, right? So they already kind of did us a favor and put all the variables on one side, right? So if we just rewrite it over here, we got x squared is equal to minus 841, right? And how would we get rid of a square? Well, the opposite or the inverse operation of squaring is taking the square root, right? So we just take the square root on both sides, right? So then we know, okay, x is equal to the square root of negative 841. So you might be thinking, okay, there's a solution right there. Why wouldn't it be just exactly 1? Well, if you put A, you would actually be wrong because the key here is they're asking about real solutions, right? And you can't really get a real number if you take the square root of a negative number, right? So you can only get square roots of real solutions to radicals or square roots if the number inside the radical is positive, right? I'll give you an example, like a different example, right? So you maybe have seen in algebra this variable I, right? This I, and it represents the number, the square root of -1, right? The reason we represent square root of -1 as I, because again, remember, it's the square root of a negative number, so that means it's not a real solution, it's like an imaginary solution, right? So just this one would be, it's a pretty simple problem if you know this concept, right? That the square root of radicals can only be, or basically the solution of radicals can only be positive imaginary numbers, right? And if you take the square root of a negative number, you would have a imaginary solution, right? So that's why our answer choice would be D, 0, right? Now, suppose you didn't remember this concept of, not taking, you can't take the square root of a negative number. Suppose you forgot that and you wanted a different way to solve this. Well, there's a slightly more, albeit maybe a little longer method that we can do that. Notice that this is an x squared, right? So x squared, that means if you have like a x squared in any function or equation, that instantly tells you that that function is a parabola, right? Or otherwise known as a binomial or quadratic equation, right? Remember, we have like this format: x squared plus bx plus c is equal to 0. Maybe you saw that in algebra, but basically that's just the way of saying that we have some sort of binomial or quadratic equation, right? So maybe you want to try solving it that way, right? So we could then try doing it that way, where we have the x squared, and then we could just, add both sides, or add 8 plus 84 on both sides, or plus 841 on both sides, right? So we'd have x squared plus 841 is equal to 0, right? So we would get to this point. Now, it's not exactly super easy to factor this, right? X squared plus 841, because again, we're missing our bx term, right? We only have an ax, and then we only have a c. So another way to kind of prove that this has no real solutions is by using the discriminant equation for quadratic equations. Now, this is a bit of an advanced concept, right? But the discriminant, when you have a given like parabola or quadratic equation, is basically represented by b squared minus 4ac, right? So there's some rules for the discriminant, right? So the discriminant, if the discriminant is equal to 0, that means there is one solution, right? If the discriminant is greater than 0, that means there are two distinct solutions. And then if the discriminant is less than 0, that means there are 0 solutions for the parabola. And recall that when we're talking about solutions for a parabola or a quadratic equation, it's basically where the parabola will touch the x-axis, right? So for this example, right, we would have a solution here and a solution here, but maybe for like a different parabola, we would have like, no solutions or no points in which the parabola touches the x-axis for like this parabola, right? Because it's kind of floating in this quadrant without touching the x-axis. So that's what in this context of solving it like a quadratic equation, that's what is meant by the discriminant and a parabola having you know, no solution versus having a solution versus having two solutions, right? So again, a bit of more of an advanced concept, but if you forgot this, you could definitely utilize this concept to solve the equation, right? Because now we have this formula for the discriminant, and we know that our a term is going to be 1. We can rewrite this as 1x. Our b term we know is 0 since we don't have any bx or just x term by itself here. And we know what c is. This would be our c term, right? So we can plug in everything we know here, right? So we have b squared, b again is 0, so that's going to be 0 squared minus 4 times 1, because remember this is the a is basically the coefficient on the x squared, and then c is going to be the constant value, right, which would in this case is 841. And you already know now, right, just by looking at this equation, that this is going to be, the discriminant is basically going to be some number less than 0, right? Because we have this huge negative number, right? Whatever 4 times 800 or negative 4 times 841 is going to be. So that's another way that you could say, okay, I know if I graphically that this equation would have no solutions, right? This parabola would never touch the x-axis, right? So that's just another way for you to basically know that the answer is D, 0 distinct real solutions. So first we talked about how we can just, quickly identify by using the properties of radicals, and how radicals or square roots cannot be applied to negative numbers without their solution being imaginary. And then the other way we did it was kind of more of a graphical method, where we rewrote this equation as a quadratic equation in standard form, and then found the discriminant, right? Where the different values of the discriminant determine uh, how many solutions the parabola, or how many times the parabola crosses the x-axis. And we found that it crosses the x-axis 0 times. So there you have it, 2 different ways to solve this problem. Hopefully one of them made sense to you. If there is any way that I can improve these videos or make them better, please feel free to let me know. As always, thank you for watching.